so you must have watched the previous two videos on linear functions. So one first video was on a linear function, where a linear function was of the order ax to the power 1 plus b is equal to y. So this was a linear function. Then you must have seen the video on quadratic function as well. A quadratic function was where ax to the power 2 plus bx to the power 1 plus c is equal to y. And we kind of saw that each of the function behaves in a very systematic manner, and you can actually predict each of these functions to a greater certainty. However, what can happen is the next functions, which is, what if I say y is equal to ax cube and bx square and cx and d. Well, if you try to learn about this function, well, yes, a cubic function will also behave in a very certain way. When you go to a function with raised to the power 4, with raised to the power 5, well, it becomes very difficult for you to keep track of what is happening. So what we've done is we're going to classify all the functions greater than quadratic functions, in fact even these two functions as well, as higher degree polynomials. So what we're going to do is we are going to classify all of them, and we are going to talk about the general properties of polynomials, right? So we're going to be talking about the general properties. So just for the start, I'm going to define a polynomial as a0 x to the power n plus a1 x to the power n minus 1 plus a2 into x to the power n minus 2, and so on. Fine. So and so on, it will keep on going on like that, keep on going on like that, and you'll have a of n minus 1 into x to the power 0. So this is a polynomial function, right? Because n can be 2, n can be 3, n can be 4, n can be 5, n can be anything. N over here is the highest highest power of x, right? So that is how you define whether this is a quadratic function, this is a cubic function, or this is a function with raised to the power 4. So yeah, this is how we define that. So this is how we define a polynomial. Now there are few properties of polynomials that I'm actually going to discuss here. The first property of a polynomial is that polynomials are continuous. Polynomials are continuous and smooth everywhere. So what does that mean? That means that you can actually draw the whole polynomial without picking up your pencil, right? Without picking up your pen. So that means that the polynomials are continuous. There's no break in their graph of polynomials. So that means they will actually keep on going on like that. And polynomials can be like this also, but they will never be, let's say, there will never be a break like this. There will never be a break like this. They will always be continuous, right? And smooth everywhere. Okay, so what do you mean by smooth? Smooth means that there are no sharp turns. So smooth means that there are no sharp turns. What do you mean by sharp turns? Sharp terms, I mean, let's suppose if I talk about y is equal to absolute of x, this is how y is equal to absolute of x looks like. This is a sharp turn. This kind of sharp turn will not be there in a quadratic function. As you can clearly see, they are pretty much smooth whenever they change their direction. Fine. And the next thing is the y-intercept. What is the y-intercept of a polynomial? So the y-intercept of the polynomial is going to be the constant of x to the power 0. So in this polynomial, this is going to be the y-intercept. Fine. So anything with x raised to the power 0 is going to be the y-intercept. What do you mean by y-intercept? Y-intercept means the value of y when x is 0. Isn't it? So all these values will be equal to 0. It's just this value which will be left. So that means this is this is actually equal to 0. Fine. So I suppose you're able to understand. I'm sorry, this is not 0. This is something which will not be 0, and rest everything else is going to be 0. So let's move forward. Let's go ahead and talk about the next test for polynomials, which is known as the leading coefficient test. Now, what do you mean by leading coefficient? Leading coefficient is the coefficient of x to the power n. So let's suppose if I say y is equal to 2x cubed plus 3x squared plus 4x plus 3, then the leading coefficient is 2 because that is the coefficient of the highest power for x. Now there is something about the leading coefficient of x, leading coefficient of this. Now if the leading coefficient, let me just write it down. If the leading coefficient is positive, then the graph will rise towards infinity on the right hand side. For example, if I say that y is equal to x cube, how does y is equal to x cube looks like this? As you can see on the right hand side on the graph is rising to infinity. Let's say y is equal to x square. Y is equal to x square looks like this. Again, the graph is rising to the right hand side towards infinity. And again, if I say that if the leading coefficient is negative, then the graph will fall towards negative infinity. So then the graph will fall towards negative infinity. If I say y is equal to negative x cube, then the graph is going to fall towards negative infinity. Fine. So that actually makes sense also, because here if I say y is equal to ax to the power n plus bx and blah 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 blah, if a is positive, that means as x increases y will increase, and if a is negative, as x increases y will decrease. Now what do you mean by as x increases y increases? It rises towards infinity. And what do you mean by as x increases y decreases? It goes towards negative infinity. So I hope you're able to understand this part as well, guys. So this is the leading coefficient test, which is also known as the right hand behavior. This is something which is also known as the right hand behavior of a polynomial. Now let's talk about the left hand behavior, right? So what do you mean by the left hand behavior? This is something that is also known as, that is something that we actually find out from the degree of the polynomial. So what do you mean by degree of a polynomial? So let's suppose if I have any polynomial where it's a into x to the power n plus, let's say, a0, a1 to the x to the power n minus 1 and so on. The highest value of n here is actually equal to the degree of the polynomial. If the degree is 2, then it's a quadratic function. If the degree is 3, it's a cubic function. If the degree is 1, it's a linear function. So that means the degree is something that can actually tell us that if the value of n is even, then the left hand side of the y-axis, would be completely same as the right hand side of the y-axis. Let's say y is equal to x squared. So as you can see, the left hand side of the y-axis is completely equal to the right hand side of the y-axis. And if n is odd, then the left hand side of the y-axis would be completely opposite to the right hand side of the y-axis. Let's say, for example, y is equal to x cubed. As you can clearly see, the right hand side of the y-axis is completely opposite to the left hand side of the y-axis. So if n is even, the left hand side and the right hand sides are equal. If n is odd, then the left hand side and right hand side are opposite of each other. Fine. So that's there. And again, you can see that if n is even, then both when n is even, the graph starts and stops on the same side of the x-axis, As you can clearly see that here the graph starts and stops at the same side of the x-axis, and when n is odd, it's actually on the opposite side. If the graph is coming from the top, it will go to the down. Fine. So if n is even, the graph will start from the top and end at the top. If it starts at the bottom, it will end at the bottom. If n is odd, if it starts at the top, it goes at the bottom. If it starts at the If it starts at the bottom, it will go at the top. So that's there. That is actually known as the left hand behavior of the function. Now let's talk about the roots of a polynomial function. Roots are also called as the zeros of a polynomial function. Now, if you have a polynomial function, let's say y is equal to ax to the power n plus bx to the power n minus 1 and so on. Well, n tells you the degree of the polynomial. Well, the function is going to have at most n real roots. Just like, for example, if you have a quadratic function, a quadratic function is going to have at most 2 real roots, right? Which is the case here. A cubic function is going to have at most 3 real roots. So if a polynomial is there and the degree is n, then it's going to have n real roots. And again, if it's going to have n real roots, it's going to have at most n minus 1 extrema. What do you mean by extrema? Extrema means it's going to have n minus 1 maximum or minimum points. So let's suppose if I have a function y is equal to x squared. The degree is 2. It's going to have 1 maxima or minima. As you can clearly see, it has 1 minima. Fine. Or you can also say that if the degree is n, the graph turns. Okay, this can also be a point of inflection also. You don't need to worry about that right now. Just understand that if you have n real roots, that means you can have n minus 1 turns in the graph. What can you have? You can have n minus 1 turns in the graph. So that means if I say y is equal to x squared, it is going to have at most 1 turn in the graph, which is this. Is that fine? So that's there. If you have y is equal to x to the power 4, it is going to have at most 3 turns in the graph. So when I say 3 turns, I mean to say 1, 2 and 3. So that is how this is going to be. So I hope you're able to understand this point over here, guys, right? So let's go ahead and move forward. Now let's talk about how do you denote the real roots of a polynomial function. So let's suppose if I say I have a polynomial function y is equal to let's say x minus 3 whole square x plus 5 into x plus 2 raised to the power 4. Let's suppose this is a polynomial. Now in here, if I equate this equal to 0, then x is equal to 3 and x is equal to negative 5 and x is equal to negative 2. These are all the roots of the polynomial. When I say roots, that means these are all the x-intercepts. When I say x-intercepts, these are all the points on the x-axis when this graph will cut the x-axis. Fine. So that is how you denote. So when I say x is equal to a satisfies the polynomial, that means equates is equal to 0, that means x is equal to a means it's the root of the function. It's the root of the function as well, and it's a solution to f of x equal to 0. Fine. So when I say x is equal to a, that means it's the root of the function and it's a solution to f of x equal to 0. So if f of x equal to 0, that means x is equal to a, that means x minus a is a factor of f of x, isn't it? As you can see that x minus 3 is a factor of this function. If you divide this function by x minus 3, it will cut this and you'll be just left with this. So that means if x is equal to a is the root of the function, that means x minus a is a factor of that function. And similarly, a comma 0 is the x-intercept of the function, as something that we've already talked about. So when I say x is equal to a, I mean to say that it's the root of the function and it's a solution to f of x equal to 0. Apart from that, x minus a is going to be the factor of f of x and a comma 0 is going to be the x-intercept. Fine. Now sometimes what happens is, as you can clearly see in this function, that y is equal to x minus 3 whole square and x plus 5 and x plus 2 raised to the power 4. Whenever this happens, as you can clearly see that these zeros are repeated. As you can see, x minus 3 raised to the power 2, x plus 5 raised to the power 1, that's just 1, x plus 2 raised to the power 4. That means these roots are called repeated roots. Like x is equal to 3 and x is equal to negative 2. These roots are called repeated roots because as you can clearly see, this is raised to the power 2, this is raised to the power 4. So what do you mean by that? So repeated roots are actually tied to a concept called multiplicity. So what is the meaning of multiplicity of a root? Multiplicity of the root is the number of times a root is an answer. For example, here the multiplicity of x equal to 3 is 2. As you can see, it's x minus 3 raised to the power 2. It's actually x minus 3 into x minus 3. So that means it's the root is coming 2 times. That means the multiplicity of x equal to 3 is 2. Similarly, the multiplicity of x is equal to, the multiplicity of x is equal to negative 2 is 4. Fine. So that's there. I hope you're able to understand what I'm trying to say here. So, and again, the multiplicity of x is equal to negative 5 is 1. Now, there are so many concepts related around multiplicity, right? So let's go ahead and understand that concept. So let's suppose if I say I have a function y is equal to x minus 3 whole square, x plus 5 and x plus 2 raised to the power 4. So as you can clearly see that multiplicity of x is equal to 3 root is 2, the multiplicity of x is equal to negative 5 is 1, and the multiplicity of x plus 2 is equal to negative 4. Now again, I'm actually going to show you an observation, kind of a beautiful thing. That is, if multiplicity of a root, is odd, if multiplicity of the root is odd, then the graph will cross that 0 at x-axis. Then the graph will cross that root at x-axis. That means if I say y is equal to x cube, as you can see the multiplicity of this root is odd. That means at x equal to 0, it will cut the x-axis like this. It will actually cross it. However, if multiplicity of a root is even, the graph will touch the x-axis. When I say touch, it will kiss the x-axis at that point. Let's say for example y is equal to x squared. The multiplicity is even, so it's just going to kiss the x-axis like this. So I hope you're able to understand what I'm trying to say here. Let's actually go ahead and graph this function on a graphing calculator and let's see whether we are right. So if you see, what I've done is I've actually plotted this graph y is equal to x plus 2 raised to the power 4 and x plus 5 and x minus 3 raised to the power 2. So the multiplicity of x being equal to 3 is actually equal to 2. So that means it's just going to touch the x-axis, which you can actually see right here. And the multiplicity of x is equal to negative 5 is 1, which is odd. That means it's going to cut the x-axis at that point. And the multiplicity of x is equal to negative 2 is actually even. That means it's going to touch the x-axis at that point. So as you can clearly see here, our observation was completely right. Fine. So I hope you're able to understand what I'm trying to say here, guys. Okay, so that's there. So now what I'm going to do is I'm actually going to define another rule which is actually very, very important. It's known as the rule of signs. So the rule of signs states that, the rule of signs actually first of all asks you to define one thing. It states that the number of times, it says the number of times the consecutive terms, so the number of times the consecutive terms in a polynomial changes signs, is equal to the number of variations in the polynomial. Let's say for example y is equal to x cube minus x squared plus x minus 2. So as you can see, it's gone from positive to negative. I'm talking about consecutive terms. From positive to negative, that's plus one variation. From negative to positive, that's again a variation. For positive negative, that's again a variation. So the number of variations this polynomial has is equal to 3. So let's suppose y is equal to x cube plus x square plus x plus 4. Here it stayed positive all the time. That means there's no variation. Let's say y is equal to x cube minus x square minus x plus 2. From positive to negative, that's one variation. Negative to negative, no variation. Negative to positive, one variation. So it has a total of two variations. So we have defined something that is the number of variations in a polynomial. Now what does this have to do with the rule of signs? Well, the rule of signs says that if that always the number of, he says that the number of positive real roots is always less than or equal to the number of variations in a function. So let's say, for example, if I have a function y is equal to x squared minus 5x plus 6. Now, how many variations it has? 1 and 2. That means it's going to have a maximum of 2 positive real roots. Let's check that out. Y is equal to x minus 3 and x minus 2 is equivalent to this function. And you can clearly see x is equal to 3 and x is equal to 2. It has 2 positive real roots. So that means the number of positive real roots is always less than or equal to the number of variations in a function. Right? Let's say that function is f of x. So I hope you're able to understand what I'm trying to say here, guys. That is the number of positive real roots. So let's suppose if you have a function y is equal to x cubed minus x squared plus x plus 2. So it has only one variation, this one, and then two variations. So it has total of two variations. So if it has total of two variations, that means it's going to have maximum of two positive real roots. Now another variation of rule of signs is, it says that the number of negative real roots is less than or equal to the number of variations in f of minus x. Right? So the number of negative real roots is less than or equal to the number of variations in f of minus x. So let's suppose if you have a function f of x is equal to x to the power 4 plus x to the power 3 minus x squared minus x plus let's say minus 18. So what do you have? Let's find f of minus x now. So if instead of x, what I'm going to do is I'm actually going to substitute that as minus x. So I have f of minus x to be equal to this. So this actually becomes x to the power 4 minus x cubed. This remains minus x squared. This becomes positive x, and this is minus 18. Fine. So let's check the number of variations here. So you have one variation here from positive to negative, no variation here, one variation here, and one variation here. So this has a total of three variations. So that means the number of negative real roots are maximum possible 3. Now another thing that the rule of sign states is that the difference between the number of variations and the number of real roots. So it says that the difference between the number of variations and number of real roots, number of variations and number of real roots is always going to be an even integer, an even number. Okay. So if you have odd number of variations, you're going to have odd number of real roots. If you have even number of variations, then you're going to have even number of real roots. Okay, so I hope that's fine as well. That's again another observation that you should be using all the time. So I hope you're getting this point over here, guys. I hope that's clear. Let's move forward to the next one. Now the next theorem that I'm going to talk about is known as the rational root theorem, right? It's known as the rational root theorem. The rational root theorem states that if you have a polynomial function, let's say this is the polynomial function, an x of n and a of n minus 1, x of n minus 1, and keep on going to a0. Let's say if I define that p are all the factors, of p is all the factors of a0 and q are all the factors of an, then all the rational roots of this polynomial can be described as plus or minus p over q. So if you have a polynomial f of x such that p describes all the possible factors for a0 and q describes all the possible factors for an, then all the rational roots will be of the form plus or minus p over q. Let's go ahead and take an example for that, guys. Let's suppose again we use the same function. Let's say y is equal to x to the power 4 plus 4x cubed minus 8x squared minus 33x minus 18. So what are all the possible values for p? So all the possible values for p would be all the possible factors for 18. That is going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. That is all the factors of 18. Q will be all the factors of 1 here, which would be plus or minus 1. So all the possible value of the roots would be p over q, which can be 1 over 1, that is plus or minus 1, 2 over 1, that is plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. These are all possible roots. These are not the roots, but these are all possible rational roots of this polynomial function over here. That means the roots cannot be besides this. These have to be the roots. Either 2 of them would be, or 3 of them would be, or 4 of them would be. Fine. So I hope you're able to understand what I'm trying to say here. Another possible way is, if you want to check out, if you know that plus or minus 1 is a possible root, that means x plus 1 and x minus 1 is a possible factor of this polynomial. That means x plus 2 and x minus 2 is a possible factor of this polynomial. That means x plus 3 and x minus 3 is a possible factor of this polynomial. Fine. So I hope you're able to understand what I'm trying to say here, guys. Right. So let's go ahead and move forward. Now the next thing that you need to know is a little bit of simplification. That is, what is a plus b raised to the power 3? So if you check out what is a plus b raised to the power 3, that is going to be equal to a cube plus b cube plus 3ab into a plus b, and a plus b raised to the power 4 is going to be equal to a minus b raised to the power 3 is going to be a cube minus b cube minus 3ab into a minus b. Another thing is that what is a cube plus b cube? That is actually going to be equal to a plus b into a square plus b square minus ab. And the next thing is, what is a cube minus b cube? That is going to be equal to a minus b into a square plus b square plus ab. Remember, I'm just reviewing these properties with you. Deriving these will take a lot, will not take a lot of time, but cumulative, when I kind of add all the derivation time, this video is going to be huge, which is why I'm actually just writing these expressions here. Okay, so now let's go ahead and solve some questions. So let's suppose, for example, I want to find out the value of x here. So this can be very simply be classified into x cubed plus 3 cubed, which is going to be equal to x plus 3 a plus b into a square plus b square minus ab. So if I want to solve for this, I have to equate this equal to 0. So either this is 0, that is x plus 3 is 0, or x square plus 9 minus 3x is 0. That means x is equal to negative 3, or we solve this quadratic function, that is x square minus 3x plus 9 is 0. So what I can do is I can actually use the expression that is minus b plus or minus square root b square minus 4ac over 2a. So I can say minus b plus or minus square root b square minus 4ac over 2a. This is going to be 3 plus or minus uh, plus or minus, this is going to be root of negative 27 over 2. So that is going to be equal to 3 plus or minus. So this is nothing but 9 times 3. This 3 will come out. And when this negative comes out, it's a complex number. So it's 3i square root 3 over 2. So that means it is going to have three roots, minus 3 and minus 3 and 3 plus 3i square root 3 over 2 and 3 minus 3i square root 3 over 2. It has only one real root. Fine. As you can clearly see that it has only one real root. Yeah. That, as you can clearly see, that it has it has no variations. F of x has no variation here. That means it has no positive root. But f of minus x, if you find f of minus x, it's going to be negative x cubed plus 27. F of minus x has one variation, which is why it has one negative root. Fine. So we're using that rule of signs to find out how many maximum number of positive and negative real roots it's going to have. So I hope you're able to understand what I'm trying to say here, guys. Let's see another one. Let's say we have to solve x to the power 4 minus 3x square plus 2 is equal to 0. So here in these kind of questions, what you can do is you can substitute like u to be equal to x square. Then this becomes u square minus 3u plus 2 is equal to 0. And now you can just solve it like a simple quadratic function, that is u square minus 2u minus u plus 2 is 0. That means u into u minus 2 minus 1 into u minus 2 is 0. That means u minus 2 and u minus 1 is 0. That means either u is 2 or u is 1. That means either x square is 2 or x square is 1. From here x can be positive or negative 1, and from here x can be positive or negative square root 2. So these are the values that are there. So I hope you're able to understand this part over here, guys. Right? So let's move forward to the next one. Let's say we have to solve this quadratic equation here. X cubed minus 8x minus 3 is equal to 0. Fine. Now tell me, what are positive rational, what are the possible rational roots of this function here? Again, we're going to use the rational root theorem. The factors of 3 are plus or minus 1 and plus or minus 3, and the factors of this is plus or minus 1. That means if I find the value of p over q, I will get the possible rational roots to be plus or minus 1 and plus or minus 3. So that means these are the possible roots that I'm saying. And what I can do is I can actually substitute plus 1, minus 1, plus 3 and minus 3 in this cubic equation and check whether they are working or not. So let's check. Let's try with 1. If I try with 1 cube minus 8 minus 3. No, 1 does not work. Let's try negative 1. Negative 1 and right. So negative 1 and positive 8 and negative 3. It's not working. So this is not working. That means negative 1 is gone. Let's try positive 3. 27 minus 24 minus 3. Well, yes, positive 3 is a root. And let's try negative 3. Negative 27 and positive 24 and negative 3. That is not working. That means only positive 3 is the rational root. That means if positive 3 is the rational root of this, if positive 3 is the rational root of this equation, that means x minus 3 is a factor of this equation. So what we do is we divide x minus 3 for this to actually find out what's happening. What's the next function, what's the next root, because the next root will be a complex root and there's no other way for us to find the complex root. So if this is x minus 3, so what you're going to do is you can multiply this x squared to actually eliminate the first one. So x into x squared is x cubed and minus 3 into x squared is minus 3x squared. So this is gone, this negative, this is positive gone. So you have 3x squared minus 8x. Now you have to eliminate 3x squared, so what do you do is you multiply by 3x. So this is 3x squared minus 9x, so that means minus and plus gone. I have x minus 3, then you just multiply by plus 1, you have x minus 3 gone. That means this into this is equal to this. That means I can say that x minus 3 into x squared plus 3x plus 1 is actually equal to x cubed minus 8x minus 3. Now I know that x minus 3 is a factor. Now I can solve this quadratic equation to get the two complex roots by using this expression plus or minus b square minus 4ac over 2 times a. So see, whatever we have learned, we've put all of that to test here. So I'm actually going to repeat what I just did here. Okay, so what I did was I had this function in front of me. I found out the possible rational roots. These are the possible rational roots. I substituted each of the possible rational roots to get one of the rational roots, and I found out one of the rational roots, that is positive 3. And then I said if positive 3 is one of the roots, then x minus 3 has to be a factor of that function. I divide this by x minus 3. I got the next possible quadratic equation, which would be divisible by this. That means then from here, using this quadratic function, I'm going to get the formula for, I'm going to get the two complex roots for for this quadratic function and for this function as well. Now understand one more thing, that complex roots always come as conjugates of each other. If one of the root is 2 plus 3i, there has to be a 2 minus 3i as well. So they always run in pairs. Fine. So complex roots always run in pairs of each other. Fine. So I hope you're getting what I'm trying to say here, guys. Right. So okay, guys, go ahead and try this question now. Okay, so it says how many possible rational roots are there for this. So how would you find the possible rational roots? You'll find all the factors of 12 and you'll find all the factors of 2. So what are the factors of 12? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. What are the factors of 2? Plus or minus 1 and plus or minus 2. Then what all possible values for p by q are there? So first of all, 1 over 1, it's plus or minus 1. 1 over 2 is plus or minus 1 over 2. Fine. So that's there. Then 2 over 2, it's plus or minus 1 again, which we're not going to consider because we already considered plus or minus 1. Then 3 over 2 is going to be plus or minus, 2 over 1 is plus or minus 2. 2 over 2 not going to consider. 3 over 1 is plus or minus 3. 3 over 2 is plus or minus 3 over 2. 4 over 1 is plus or minus 4. 4 over 2 is 2. I'm not going to consider that because there's already a 2. 6 over 1 is plus or minus 6. And 6 over 2 is 3. That means there's already a 3. I'm not going to consider that. And 12 over 1 is plus or minus 12. Not going to consider 12 over 2. Fine. So now what we do is we go ahead and find out the number of possible roots. That's 1, 2, 3, 4, 5, 6, 7, 8. 8 times 2, that is 16, because there is a positive and negative variation as well. That means my answer is going to be option E. So I hope you're able to understand what I'm trying to say here, guys. Fine. Okay, so I will actually ask you to go ahead and try out this question here. So this question says that write the equation of lowest degree with real coefficients if two of its roots are -1 and 1 plus I. So as you know, if one of the root is 1 plus I, the next root is going to be equal to, if one of the root is 1 plus I, the next root is going to be equal to 1 minus I. And since I have to write the equation of lowest degree, if an equation has 3 roots, I'm actually going to say x plus 1. If -1 x is equal to -1 is a root, that means x plus 1 is actually x plus 1 is actually a factor of that equation. If 1 plus I is there, then x minus 1 plus I is there. And if x1 minus I is there, then x minus 1 minus I is there. And let me equate this equal to 0 because I want to find the equation of the lowest degree, right? So that means these 3 are going to be the roots of that equation. right? There can be more roots as well, but I have to write the equation of the lowest degree, so I'm going to consider these 3 roots and no more roots. So this is going to be x plus 1, and this is going to be equal to x minus 1 minus I, and this is going to be equal to x minus 1 plus I. Fine. So let's say this is x minus 1 minus I, this is x minus 1 plus I. So this is nothing but a minus b into a plus b, which is actually equal to a square minus b square. So that is going to be x plus 1 into a square, that is x minus 1 whole square, minus b square, that is minus I square. So what is I square equal to? I square is equal to negative 1. I square is equal to negative 1 because I is square root of minus 1. So negative 1 and negative is going to cancel out. It's going to give you a positive 1. And then if I just open this up, this is going to be equal to x plus 1 into a square plus b square minus 2ab plus 1. So this is going to be equal to x plus 1 into a square plus 1 plus 1, that is going to be 2 minus 2x. Then I'm going to open this up. I'm going to multiply each term by x first. So it's going to be x cubed plus 2x minus 2x squared. Then I'm going to multiply each term by 1. That is going to be x squared plus 2x, x squared plus 2 minus 2x. So this is going to be equal to x cubed plus 2x and minus 2x. It's going to cancel out completely. Minus 2x squared and plus x squared is minus x squared plus 2 equal to 0. That means my answer is option D. So I hope you're able to understand what I'm trying to say here, guys. So we actually use the concept that the conjugate roots are kind of come in pairs. They come, the complex roots come in pairs. That's what I wanted to say. Fine. So thank you very much for watching this video, guys. Just so that this video doesn't become big enough, I'm not doing a lot of questions, but I'm going to be making another video where I'll do a lot of questions on this topic, right? So this would be about this video for high degree polynomials. I hope you're able to understand all the concepts here. So we did the left, so I'm just gonna summarize we did the left hand behavior, we did the right hand behavior, we did the rational root theorem, and we did the rule of signs, right? And we did that the complex numbers always come in pairs. So basically these were the 5 important parts of a higher degree polynomials which were important for your subject, right? So thank you very much for watching this video, guys, and keep watching. I'll see you in the next one.